So my thing is not so much in VR, although I do like VR a lot. My whole thing is video games, and I've been a fan of video games ever since I was a kid. And I've always sort of been fascinated by how you can learn through games, and bit by bit, that's sort of become well, that's what I do now for my job. So our company is called Play Curious, and we make games to learn topics in science and technology. Um, so, well, why video games? Well, for some of the same reasons that Anne-Sophie was talking about VR. It's all about learning while you're doing, right? You're doing something, and by being active, that's the best way to learn. And it's interesting because it's true that nowadays we see so much online video, which is great. You know, it is something that's very engaging as a way for people to learn, but it doesn't replace, there's nothing interactive about it, right? There's nothing that you're actually doing that's gonna help you learn better or remember. And when you play a game, on the other hand, the player is constantly exploring, right? You're trying out something. You say, well, what happens if I do this? What happens if I do that? You try this thing, you try that thing, and then bit by bit, you kind of discover how it works. And even though you may fail many, many times along the way in a game, you don't give up quite as easily, because in a game, there's all these things that are done to make it fun. So, you know, one of the classic things in game design is making failure fun. So, you know, when you die in a platformer, for example, you know, it goes, and you have these sound effects, and you know, there's things on the screen. So even when you lose, there's something that's rewarding about that, and it makes you want to try again, and you get really into the challenge. And this ultimately leads to people learning from their mistakes. And so, you know, obviously, you know, educational games have been around for a very long time. For example, SimCity is quite a classic example, and there were other games before that. There's games such as Kerbal Space Program, where you can literally like build a rocket and go off to the moon. It's in a very, very detailed way. You have multiple stages. It's very complex. And there's games also that are a little on the simpler end, like Earth, a primer. We're more like done for an iPad kind of interface. So our question is, if video games, like I'm saying, are really the best way to learn, how come we don't see more of them? And the conclusion that we've come to, and it's not that, you know, to be clear, there are some, right? But it's not something that we see a lot of. They're kind of rare. And we identified 3 problems of why there might not be as many games as there should be in our mind. One is that kind of like a stigma around the idea of an educational game. There's something in the term educational game that doesn't sound good. Maybe because we think of education as being something that we have to do, like our parents make us do it, or maybe it's the society makes us do it. But you know, so, and that takes out kind of another notion in game, which is that you could choose, right? So that could be that. But in any case, the term doesn't work well, and that's hard, I think. Another is that a lot of games are made that are for learning, are made by educators who maybe don't have the resources or the know-how to do a really good job, you know. So it's normal, you know, AAA games these days are made, you know, it's, you know, millions of dollars of budget, years and years of work. So it's not something that, you know, most people can just kind of cook up on their own over the weekend. And finally, on the other side, some of them are very sophisticated, but so sophisticated that it actually takes a lot of time to get into. So in the example I gave earlier about Kerbal Space Program, it's a wonderful game, but it takes hours and hours before you can even, you know, succeed your first mission into space. It's not something that you can just pick up like that and start playing with. I mean, you can play with it, but you won't succeed right away. So to integrate that into as a learning thing can be kind of intimidating. So our approach basically is to try to break down these barriers, first by making a casual format. So for mobile and for web, that's our format that we use. So it's a little lighter, right? It's like it's all 2D games for the time being, and they run on a phone. So it's really kind of a low barrier to entry. Everybody has a phone. It's easy to install our games, or you can even just play them in a web browser. We really work on having engaging graphics and sound and exciting design to get people wanting to play. And we work through existing networks of science enthusiasts and influencers like YouTubers in order to get our games out to people who are already interested in that topic as a way to kind of take on the stigma. So our basic idea is to try to make these games in order to build up a community of players who are excited about educational games. And so to give you just a very quick example, here are 2 games that we've made. So, but Blockchain Battle is all about cryptocurrency. So we basically explain how Bitcoin works, and we actually really explain it, like the math and the computer science behind it. through a game, and it's something we've shown off at Paris Games Week and Stumpfest, and we were able to also turn this into a full online class where we added a bunch of additional videos where we present concepts that we couldn't show in the game. And another game that we showed off last week at a festival in France, but we're still working on the finishing touches on. It's called CRISPR Crunch, and so there we explain CRISPR, which you don't know is a technique for genetic editing, and we basically explain the origins of CRISPR and how scientists discovered it. So it's a very different kind of game, and I'll talk about that if we have the time. All right, so the topic of today's webinar is all about gamification, and I think gamification is really interesting because obviously my whole thing is to make games, right, as a way to learn. So my first read of gamification is awesome. It's great. Let's do more of it. However, I feel like there are a few kind of pitfalls or danger that we can fall into when we think about gamification. I think there's maybe two major ones. The first is the famous chocolate-covered broccoli, if you've heard that metaphor before. So here the idea is, you want to get a child to eat broccoli, which they say they don't like, and so you cover the outside with chocolate and you try to get them to eat it. So if here the chocolate is the game part and the broccoli is the actual content the learning content you want to get them to read, right? Like it might work at first. They might take a good bite, but pretty soon they'll realize that the chocolate was just on the outside and that, there's just kind of a superficial layer of game and a lot mostly of something that they would typically consider boring. And so not really that motivating. And I think that's maybe gets back to why people think of educational games as not being real games. I think the other danger is kind of like the Skinner box. So for those of you who heard of that, it's where B.F. Skinner was a psychologist studying how rats and pigeons react to signals after he basically trained them using giving them lights, and then they could press a lever in order to get either food pellets or get shocked, and I feel like sometimes gamification falls into that trap too, not necessarily of shocking people. I mean, I hope we don't do that, but there is a little bit kind of thing of taking something that's a little bit boring and basically rewarding people. Maybe it's with money or maybe it's with points, and you're basically giving points to people all the time a bit, and it becomes something a bit kind of like gambling, where it's like gambling, like in a casino, for example. We call it a game, but it's not really a game because you're not doing anything that makes any sense. You're really just kind of like, pulling a lever and seeing what happens. But it does activate something in our brain that makes us want to try it because we kind of think that we can somehow outsmart the system when in fact we can't. So if you think about these two examples, right, that are kind of extreme, I think we can say, well, the problem here is that we're basically just sort of making just like the most superficial, thinnest layer of game over something that's not fundamentally a game, which is kind of ironic because actually there's a whole theory that the feeling of fun when we're excited about we're having fun is basically about learning. So there's a famous book called The Theory of Fun by Ralph Koster, which I highly recommend if anyone wants to read it. It's a very short book, but excellent. And it's based on a quote by Chris Crawford, another famous game designer, who said, "Fun is the emotional response to learning." And so basically the theory here is that over time, as a way to survive, right? Humans have gotten a lot out of having brains and learning things, right? It helps our survival, and so we would have evolved basically to get rewarded for learning. So when we learn something, our brain is rewarding us, right? So it's rewarding us through kind of our feelings of curiosity, and it's also rewarding us through the feeling of satisfaction when we learn something and we get it right. And so in this sense, we can say, well, learning really is fun to start with, right? And so if that's the case, and that's what we try to do, what can we do to try to maximize that fun while we're making a game for learning? To drive this point home maybe a little bit more, it's interesting to think about kind of the general feedback loop that you get both when you learn and when you play, and in fact they're really kind of the same, or at least they're very, very similar. So if we take an example of playing a game, let's say we're going to play, I don't know, soccer or something like that. Okay, so I want to play soccer. I have the ball. How do I play? Well, my first thing, I would probably start by fixing my goal. I want to, get the ball in the net. So, I act, I start doing something. I'll try to shoot from really far. I give the ball a big kick. I see what happens. Well, it doesn't work at all. It goes way out, and I lose the point. I lose the ball. So I evaluate the situation again, and I'm like, okay, that didn't work because I was too far. Maybe if I can get in a little bit closer, I can do better. So I fix a new goal. I act. I try to dribble around somebody, and I shoot from closer. And maybe I get it in, right? In which case, that's great. Or maybe I don't. In which case, well, I didn't get it in. Maybe I need to evaluate the situation and fix a new goal, right? So we see it's this cycle. And what's really interesting is that this cycle is really fast in a game, right? Typically, we're talking about something you do very quickly, and you're getting the feedback right away, and that's extremely rewarding. Whereas often in a learning situation, like just take a very typical situation at school. So I'm also a teacher, for example. I teach game design and I teach programming. So I also have that experience of doing that. Typically, well, I will, I'll teach the students something, and then I'll give them a test. Right, that's the typical thing. So there might not be many tests. Maybe there's just a test at the end of the year, or maybe every few months or something. So, well, in that case, sure, they're still fixing a goal. They're still acting by doing well in the, trying to do well in the test. But the observation stage, this can take way longer. Like by the time I correct the test, maybe a few weeks have gone by. They've kind of forgotten like what they did on the test, right? And so this feedback loop it's still there, but it's very slow. And sometimes it's not even there. Sometimes people will, just get a grade and be like, well, whatever. In any case, the semester is over. I don't care. In which case, it's actually broken, right? And so that's not rewarding. And I feel like that's what we're trying to get at when we're trying to make games, is trying to make these interesting choices that make that feedback loop fast, even when you're learning something that might be more of it in a school situation. So let's see. I hope I have a little time left. I want to talk quickly about our process as a way maybe to inspire other people. You maybe be interested in making your own games, how we go about it. So here are a few steps in our process. One of the first things we do is we try to identify the systems involved. And the reason why it's interesting to identify systems is that that kind of shows the cause and the effect that you could possibly use in your when you're making a game about it. And anything that's systematic is really nice for games, because games either through like board games or through a video game, there's going to be some kind of like mechanistic rules, right, that need to be applied. And those mechanistic rules are pretty nice if they can identify a system. So if you think of SimCity, the classic city builder game, right, there's rules about how what happens when you have a road next to a house, or a road next to a store, and that kind of thing. And all those rules will kind of get simulated in the end to figure out what happens. And even if the rules aren't written out concretely for the players, the players figure them out, and that's a lot of fun for the players to figure out how they work. Second major step, we'll find the fun, right? Try to figure out which part of this simulation or this kind of system that you've built is fun. And this sometimes takes a while because, it's not necessarily the first thing you think of, and it takes a little bit of playing with it to try to figure it out. Another major idea that we get is to try to get inspiration from other games, from existing games. And this is, often when I've done this before, because I've run workshops before, with students and with teachers, where we come up with games. And unfortunately, a lot of people's inspiration tends to be like Monopoly, and like quiz games, which are fine. And there's nothing wrong with quiz games, and there's nothing wrong with Monopoly. But it's, if the more games that you can base yourself on, the people who play a lot of games, for example, a lot of board games, they have a lot more inspirations that they can draw on, and it makes it easier for them to come up with cool ideas. Another important point is that not everything has to be real. I feel like sometimes when we're making a game, a trap that I've fallen into before is to working hard on trying to make everything kind of be realistic, because we want to teach people things. But of course, in a game, a lot of the fun comes from things not being fictional, So you don't have to be afraid of making the whole thing take place in a fictional world, or adding entire systems and mechanics that aren't real at all, as long as it's clear to the player, like which parts are supposed to be real and which parts aren't. And finally, it's interesting to also evaluate both the learning aspect and the engagement or the fun at the same time. And that's something that they talk about a lot in this book over here, Values That Play in Digital Games. There's a whole process to how to do that. But it's something that you really kind of have to do, because it's very easy for one side to kind of tip the scale. You know, you work something, you try to make it more and more fun, so you make it more and more fun, but the learning part kind of disappears, or vice versa. You work really hard at making the learning work, but then the fun kind of falls out, and you don't have what your result. So it's a careful balancing act. So I want to very quickly just take you through how we did this in our games. So, for example, the blockchain battle game, where we did everything about Bitcoin. Well, we basically started by taking the Bitcoin paper, the original paper by the famous Satoshi, and broke it down into its concepts and kind of rebuilt it into a simplified blockchain simulation. And so that's what our game is based around. So in the game, you play a hacker, where you're kind of trying to hack the system, which for us we kind of imagined as you're trying to cheat, and you're trying to fake out and trying to find a flaw in the system. And with a whole narrative angle where you're trying to figure out who the other characters are, we were inspired through a lot of adventure games. We tried to keep the truth of the systems are real, but everything is very simplified, right? Everything is kind of a toy. It's like a toy system of a blockchain. And we evaluated that also in high schools in Perpignan and in Toulouse as well. And for our second game, CRISPR Crunch, so this is a mobile game where you're trying to match these sequences. So you have a virus is going to inject a sequence, a DNA sequence, and here is your DNA. So here we represented, these are DNA. It's not real DNA though, right? Like we didn't use letters like A, T, C, G. We used colors. We tried to make everything very colorful and bright to try to make people want to click on things, right? So that's the engaging part. It's not real, but what the real part is that there are really these bases, and you're trying to match them, and we are inside a bacteria, and you're trying to kill the virus. So that aspect is real. And we then also kept up a whole lot of extra science things through additional videos. Right. So the very last thing I wanted to say before I let you go is about game jams, because I don't know if you're familiar with that, but if you're not, they're a really wonderful thing to both participate in and also to maybe organize. So game jams are kind of special kind of event, a bit like a hackathon, if you've done a hackathon before, where people get together, usually over a weekend, and you have some kind of like theme that will be revealed usually at the last moment. So everyone will get together on a Friday night, and we say, okay, the theme is games about exploration, for example. And then people get to think of ideas, they pitch each other ideas, they create teams on the fly, or maybe they've come with their friends, but usually they create teams, and then they get to work. And all through the weekend, they work on making their game. On Sunday, they come up with a game, they have a game to show, and they show it off in front of everyone. So I've organized a bunch of game jams, both in Paris and in here in Perpignan. We just did our fourth edition of the Perpignan Game Jam, and we did it remotely because of COVID and all that. So it can be done both remotely and in real life. In real life, it's a bit more fun, to be honest, but both things can work. And I found this really great as a way to also start a project when you're trying to think of a lot of different ideas, because it has this kind of crowdsourcing aspect to it. Like if you give a theme, for example, I did this once in Paris on the theme of human rights. We worked with Amnesty International, and we made a game about we made a game jam about human rights. And so it was interesting. Amnesty International presented their concept. They talked about human rights defense. And after that, everyone kind of made games about human rights. And at the end, we had a few different concepts that were super interesting that probably we wouldn't have thought of by ourselves. Whereas here, by having a lot of people do it at once, you come up with some really wonderful ideas. So besides that, well, we've worked with a bunch of different partners here in France and also abroad. And if you'd like to hear more about making educational games, of course, I would love to hear from you. Our name is Play Curious, and we're at playcurious.games. And this is my email, jesse@playcurious.games, if you'd like to get in touch.